Example 1. Okay, copy the picture. Yes, I wanted you to draw the picture, so hopefully you did. Nice job, Caleb. Nice pictures. Thanks. Okay, so copy the pictures above. Draw the distribution of charges as a negatively charged rod is brought near the electroscopes. So, to start out, how many charges, or what's the charge on the electroscope? So the left picture, what's the charge on the electroscope? Neutral. Neutral means it has as many positives as it does
negatives.
Negatives. So, I started out. Let me zoom in a bit. Be helpful. We need some like zoom-in music. Too late now. Too late now. Okay. So we might start out with, let's say 1, 2, 3, 4, 5, 6 of each. Okay. 12 total charges, 6 of each phase. Okay. Now, when we bring this negative charged rod near the electroscope, what happens? Do the positive charges all go up to the negatively charged rod? Why not? They like negatives.
Positives don't move.
Positives don't move, right? So we have positive charges that are evenly distributed. 1, 2, 3. I can't count. There's 5. I'd say 6. Okay. There's 5 positive charges that are evenly distributed, right? But what happens to the negative charges?
They run away.
Oh yeah, you're right. They go where?
All the way down to the magnet.
Good. They move away. Okay. So the 5 negative charges, they don't like this negatively charged rod, so they start moving down. Now they also don't like each other, so it's not like they're all going to cram onto the bottom of the leaves, right? So they don't like each other, but they also don't like that negative rod. So they'll evenly distribute far away from that rod. Okay. Does that make sense?
Okay, so you start with like positives.
So the positives are where the negatives were, because the positive charges aren't allowed to move.
What happened to the negative charges
From here?
Yeah.
They all move down. So there was a negative here,
so they go
it
to
moved
the
down. There was a negative here,
Oh, so it's not touching.
it moved down. Right, they're not touching.
Oh, so you don't put electrons.
Right, we don't add any electrons on.
Okay, that's all.
If this were to touch, then we gain more electrons, but they're not touching. Okay, so we're not gaining any more electrons. So now the leaves, each leaf has a overwhelming negative charge, because we have more negatives than positives. Right? Now you're saying it's just one more negative. But in real life, there's billions of charges here. Right? So it's not just one negative, it's probably hundreds of, or millions or thousands, whatever. It's some large number of negatives that move down to the bottom of the leaves. Okay. So now these leaves are overwhelmingly charged negatives. So the 2 negatives, do they like each other? Do they like each other?
No.
No, so they do what?
They separate.
They separate. Okay. Then when the negative rod gets pulled away, what happens to these negative charges? Do they stay where they were? No. They move back up, right? Because remember when I brought the rod close to the electroscope but I didn't touch it, once I took the rod away, the leaves went back to normal. Right? The leaves stayed the same. So what that means is that the negative charges then evenly distribute like they were before the rod even came by. Does that make sense? Does that make sense, guys?
Yes, it does.
Okay. No! The next question says, what if a positively charged rod was used instead? So instead of having a negatively charged rod here, let's say this was a positively charged rod. What would happen to these negative charges? They would all go up, right? They'd be attracted to that positively charged rod. They'd all fill up in the top of the electroscope. They'd be evenly distributed around, but they'd get as close to that rod as they could. So what would happen to these leaves? Would they suck in?
No.
No. They do what?
Expand.
They'd still stay out. Because once those negative charges all go up, we're left with a positive charge on the leaves. Do positives like each other? No, so they push away. Same result, different charge. That's why it can be kind of confusing. Does that make sense? Any questions? No questions? All right. Number 3, you can't see from here. Are electroscopes made of insulating or conducting material? Insulating or conducting material? Do insulators let charges move? No. Do conductors let charges move?
Yes.
Yes. Do electrons move in the electroscope?
Yes.
Yes. So it must be a conductor. Does that make sense, guys?
Yes, sir.
Any questions?
Yeah, does that say 5.2?
Your homework